All right, welcome to the Explainer. Today, we're pulling back the curtain on how AI actually sees the world. And believe it or not, the secret to its incredible power and its sometimes, well, baffling mistakes, it all comes down to one single concept: the token.
So, let's kick things off with a puzzle. It's something you've probably run into yourself if you spent any time playing around with an AI like ChatGPT.
I mean, how is it possible, right? How can these incredibly advanced models write, a beautiful poem or even break down a super complex legal document, but then turn around and get totally stumped by a simple little word puzzle?
Yeah, think about it. On one hand, you've got an AI that can literally ace a graduate-level exam. But on the other hand, it gets completely fooled by a word like movestable, and it just can't figure out that the word moves isn't in there. It's this wild contradiction that's just fascinating.
So what gives? Well, the answer isn't really about intelligence in the way we think about it. No, it's about something way more fundamental. It's all about how the model sees the text we type in.
And that right there brings us to the core idea of this whole explainer. Look, if you really want to get how a large language model works, you absolutely have to understand tokens.
Okay, so when you type a sentence into an AI, it doesn't see letters or words like you and I do. Not at all. Instead, it's like it takes a hammer to your sentence and shatters it into smaller pieces. And these pieces, these fundamental building blocks, are called tokens.
The brilliant AI researcher Andrej Karpathy has this perfect way of putting it. He says, think of tokens as the atoms of text. The model isn't reading in our sense. It's just processing long sequences of these textual atoms.
And this difference in perspective is absolutely crucial. So, for instance, where you or I see one single word, like tokenization, the AI, it might see three totally separate, kind of weird-looking tokens: token, is, and ation. It's a completely alien way of seeing language. But it doesn't stop there. The process actually goes one step deeper. See, neural networks don't speak English, they speak math. So every single one of those unique tokens gets assigned its own number, a token ID. Suddenly, hello world isn't text anymore. It's just a string of numbers, like 154.96 and 995.
Okay, so this probably has you wondering, how in the world does the model decide what gets to be a token? I mean, who makes that choice? How does it even build this vocabulary of text atoms to begin with?
Well, a lot of models use this really clever algorithm called Byte Pair Encoding, or BPE for short. You can think of it as a data-driven process. It starts super simple, with just a vocabulary of individual characters, and then it intelligently builds itself up from there. So what it does is it scans this just massive amount of training data, and it looks for the most common pair of characters that show up next to each other. So let's say it's U and G. It merges them to create a new token, Yug. Then it keeps going. Maybe it merges H with Yug to make hug. It just does this over and over thousands and thousands of times, building up this big vocabulary of common parts of words.
And this whole approach is it's genius, really, because it means the model can handle words it's never ever seen before. It just breaks them down into smaller pieces it does know. It's this perfect balancing act between keeping the vocabulary manageable and being able to make sense of basically any text you can imagine.
Okay, so now that we've got our heads around tokens, let's circle back to those weird AI quirks we started with. Because trust me, they're about to make a lot more sense.
All right, take this super simple comparison. Why would a powerful AI that's totally capable of doing complex calculus get this wrong so often?
And here it is. The aha moment. The model isn't comparing numbers, it's comparing tokens. To the AI, 3.11 isn't a number. It's just a sequence of tokens, one for 3, one for the period, and one for 11. It has no built-in intuitive understanding that the token 11 should be considered a smaller value than the token 9 in this context.
This token vision, if you will, explains so many of the other weird things we see. Why are they bad at spelling? Because they see subwords, not individual letters. Why can't they count the number of R's in strawberry? Same reason. It's why they can be totally tricked by those adversarial words like movable. And yeah, it even explains why they might forget something super specific like solid gold Magikarp, if that token just wasn't common enough to make the cut during training.
And this is the really cool part. Here's the twist.
This whole token-based system, it's not just a bug, it's a feature. It's not just a weakness, it's also the very source of the AI's incredible power.
So where does that power come from? Well, it's from a mechanism that's literally called attention. What it does is let the model look at all the tokens in a sentence and figure out the relationships between them. Which ones are most important to which other ones. And that is how it understands context. It's how it knows that the token "it" refers to the animal here, but to the street over there.
So, you take all of this whole unbelievably complex system, and you realize it's all built to do one surprisingly simple thing, and that is to predict what comes next.
Yeah, I know. A diagram like this looks intimidatingly complex, and to be fair, it is. But this entire system, the famous transformer architecture that powers everything from ChatGPT to, well, almost every major AI, it has just one single core job. Look at a sequence of tokens and predict the very next one in the sequence. That's it. That's the whole game. Everything else you see is just there to help it do that one task really, really well.
And that is why you hear so much buzz about things like Llama 3's new, bigger vocabulary. 128,000 tokens. It's a huge deal, because having a richer, more diverse set of these text atoms just means the model can process language and even computer code way more efficiently, and that efficiency leads directly to a much more nuanced, much better understanding of the world.
So, all of this leaves us with a pretty mind-bending final thought. For now, our models have learned to think in tokens. But what happens next? What happens when we build models that can see the world without them, that perceive information in a completely different way? What new abilities, what new kinds of intelligence will they unlock? That, right there, is the big question that researchers are racing to answer right now.